Next, we studied about the chloroalkyl process. Correct? Lakshit, why it is called chloroalkyl process? Lakshit, why it is called chloroalkyl process? Aditya, why it is called chloroalkyl process? Correct, tell.
Like the base will dissolve in the water.
Okay, dissolve in the water.
When electron pass through an aqueous solution, then this chlorine
and alkaline is formed in as a product. Product what we will get?
Sodium hydroxide
NaOH plus chlorine gas plus the hydrogen. So a chlorine gas is produced from this reaction or from this process, and a base which is alkaline in nature. Alkaline means the base which dissolves, we call it as alkaline. Okay, alkaline means the base which dissolves in the water, we call it as alkaline base. So NaOH is an alkaline base. So that is why we call it as chloroalkyl process. What is the equation? Tell me once, anyone, equation for this process?
2NaCl plus H2O.
2NaOH
plus Cl2 plus
H2.
Pass through electron.
NaCl plus H2O, that is, we call it as brine. That when current is passed through that, then what we get? NaOH plus chlorine gas plus the hydrogen gas. Chlorine gas, it is Cl minus. So we get it at the anode. H2 plus, it's a positive ion. We get it at the cathode because positive ion gets attracted towards the negative terminal. Correct? So it gets attracted towards the negative terminal. That's why hydrogen gas is obtained at the cathode. It is obtained at the cathode. And this process, we call it as, this process is electrolysis process. And here, this we call it as chloroalkyl process because chloro means chlorine is produced. Alkyl means an alkaline is produced, that is NaOH. Okay. And electrolysis process, why it is important? Because we get an accuracy more than 99%. Whatever we get, chlorine, hydrogen gas, NaOH. So that is why it is a very important process. And even refining of metals will come there. No, most of the metals are refined using electrolysis process only. Wherever electrolysis process is there, there will be two electrodes, one electrolyte, and current is passed through the electrolyte. Then products are formed. One you will get at the anode, the other at the cathode, like that. It's a common thing. Okay. So these processes are very important because practically it is used process. Even electroplating and all they say, right? That is also done through electrolysis process itself. Okay. So maybe electrodes are different there. Electrolyte is different, but they use the same process. And accuracy of this process is more than 99%. Okay. That is why we use this process. Then we studied about bleaching powder. What is bleaching powder? Calcium oxychloride. Calcium oxychloride. It is the bleaching powder. That is the chemical name of the bleaching powder. So what is the formula for that? CaOCl2. That is the so calcium hydroxide. Okay, when combines with the chlorine, we get CaOCl2. This is calcium oxychloride, that is the bleaching powder, plus the water. So, and here, see that smell in this bleaching powder is mainly due to the chlorine gas present in that. Okay, chlorine present in that. And where the bleaching powder is used? Bhavi, where bleaching powder is used? To bleach what? Clothes, cotton. So it is used as a bleaching agent in the textile industry, not on the clothes, directly on the clothes. It's a bleaching agent to bleach the cotton, not the directly the clothes. Okay, it's a bleaching agent which is used in the cotton industries and to bleach the pulp, wood pulp. In the paper industry also it is used. Then it is used to like kill the germs in the drinking water. Okay. So chlorination of water, what they say, no, that is the one. Even in the swimming pools, they use the chlorination of the water. Means if they put that bleaching powder, what happens? It kills the germs present in that. To that they use, even in the whatever we get in that from the corporation also, we actually they will put some powder, not in a large quantity, in a smaller quantity they put the, and they leave it for 1 day, 2 days, so that it will rust and it will kill the germs, and that whatever remaining powder will be there, right, that will rust. Okay. So there also we use the bleaching powder, which will kill the germs present in the drinking water. For that purpose they use. Not in large quantity, but a very smaller quantity they use that. Okay. So they use. Next we studied about baking soda. So what is the formula for baking soda, Netra?
NaCl plus H2 plus CO2.
Yeah, full equation. First formula for baking soda.
NaCl3.
NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. That is the baking soda. How it is formed? Correct.
By heat, it forms Na2CO3 plus H2 plus CO2.
Okay. First, how it is formed?
NaCl plus water plus carbon dioxide.
Forms NH4Cl plus NaHCO. Correct. Then, when you heat this formula to heat that, then NaHCO3, when you heat the, you will get sodium carbonate plus the water plus the carbon dioxide. Okay. So, why it makes the food spongy in nature or soft in nature? When you put some baking soda, the batter becomes soft, correct? Or spongy in nature. Yeah. Correct. Carbon dioxide. When you heat with the baking soda, what happens? Carbon dioxide is released. So when it escapes from that, what happens? It becomes porous in nature, and that is why it becomes spongy and soft in nature. Okay. Then what is baking powder? Gavin, baking powder. What does it contain? Only tartaric acid, correct. Tell. With that? Carbon dioxide. Sure. Pavan? Good. Correct. Good. So when you add tartaric acid to the baking soda, we get baking powder. Okay. Why they use baking powder instead of baking soda? So it doesn't become bitter. That is the reason food doesn't become bitter. So that we use that. Okay. So when you heat that, what actually we get is the baking powder. When you heat baking powder, we will get sodium salt of the acid. So that is not bitter in taste. That is why we use baking powder instead of baking soda. Okay. Next comes the washing soda. Okay. Tamin, you can see the screen. Okay. Washing soda, it is sodium carbonate. Okay, with that you have 10H2O. Okay, it is sodium carbonate decahydrate. They call it as decahydrate. Deca means 10. Okay. decahydrate. It's not given here. Sodium carbonate, decahydrate. Okay, so that is washing soda. That is Na2CO3 10H2O. Okay, why? See, it is not plus H2O, it is 10H2O. We write like this. That means every sodium carbonate has combined with 10H2O molecules. See, if you take one drop of this washing soda and if you try to see that every molecule of sodium carbonate contains 10H2O molecules attached with that. It's just mixed. See, here it is, water is just mixed with it. But here, every 10 molecules are bonded with Na2CO3. So that is the difference. Just combining to each other, that is different from making a bond. That is Na2CO3. It has 10H2O molecules bonded with that. Sorry, not one way if you write like that. Wait. Like this. Just close the door. Like this, 10H2O molecules it has combined. If every Na2CO3 has made a bond with 10H2O molecules like this, that is why we write like this. Here it is not like that. Just CmOCl2 plus H2O is mixed with it. Okay, they are not bonded with that. So if you see here, every molecule contains 10H2O with that. That is why you write like this. So this is sodium carbonate decahydrate, which is the washing soda what we use. Okay, there is a difference between detergents and washing soda. Washing soda actually, this is better. Washing soda will be better when compared to detergents actually. Okay. There are different salts. First thing, here washing soda actually it doesn't work with the hard water, whereas detergents work with the hard water. But it is washing soda is better for clothes when compared to detergents. They'll not spoil more, like that upper layer will not be glow actually. The glow of the cloth it will be there with the washing soda. It is better for clothes when compared to detergents. But washing soda, they don't give lather with the hard water. Whereas detergents give lather with the soft hard water also. That is the major difference. Okay. So and Na2CO3, it is what? It is a base, right? So it is a basic salt, what we get here. Okay. So write down one note. Recrystallization. Recrystallization of sodium carbonate. Gives washing soda. Another one is the plaster of Paris. What we use plaster of Paris for the actually now we use for the in houses for the decoration purpose, right? There we use the like false ceiling and all. They use the plaster of Paris. They use okay, and plaster of Paris they use by the doctor for the fracture thing they use. That is plaster of Paris. So there is something called gypsum, correct? Gypsum and plaster of Paris. So, what is the difference between a gypsum and the plaster of Paris? What is the difference?
It changes the design.
Correct. See, this is see. Plaster of Paris. Plaster of Paris. This is CaSO4, calcium sulfate, semi-hydrate. Okay. This is the plaster of Paris. Gypsum It is CaSO4 2H2O. Okay, it is 2H2O. So plaster of Paris, mainly why it is used for false sealing and all they use, and it is used by the doctors for the fracture purpose. Okay, so for repairing the fracture and also they use that. So when you see plaster of Paris, it's a white powder. Okay, plaster of Paris, it's a white powder. When you mix some water to it and leave it for some time, it becomes the gypsum. Plaster of Paris, it's a white powder. If you mix some water to it and leave it for some time, it becomes a hard mass. That we call it as gypsum. Okay. So in the plaster of Paris, it has half H2O. Half H2O means what? Will it, that half molecule, it will, how you will get CaSO for half H2O? Or how the bonding will be there for that? I'm writing CaSO for half H2O. How it will be, the molecule structure, if you write, how it will be. Half you can't cut that molecule, right? See, two CaSO4 molecules combines with one H2O. When you see in the this one also, the each molecule will be like this. That's why it's given CaSO4 half H2O. Okay, two CaSO4 molecules combines, makes the bond with one H2O. So that is plaster of Paris. When you mix some water to it, it becomes gypsum, which becomes a hard mass. So why they use in the fracture thing? When they can mix with the water, whatever the way they want, they can put it. And if you leave it for some time, it becomes a hard mass. So that bone will not move. Whenever it will not move, actually, inside it will start healing. That is, actually, it will start joining inside. It happens on its own, but you have to just leave it at the rest for that bone, right? So that's what they do. They will put the plaster of Paris mixed with the water and just they apply there so that it becomes a hard mass. So that bone will not move much. That is the reason they use that. And even in the false sealing nowadays, we use it more, right? Because it becomes a hard mass. We can mold whatever way we want after mixing with the water. After molding, it becomes a hard mass. So that is why it is also used in false sealing. Okay. So plaster of Paris formula is CaSO4 half H2O. It will be like this. When you mix with the water, it becomes a hard mass. Then it becomes a gypsum that will be like this. CaSO4 2H2O. That is here CaSO4. With that, you have 2H2O. Okay, so this is a hard mass. This is a white powder. This is about that. Then this what do you call that? The chemical name CaSO4 half H2O. Write down this. It is calcium sulfate. Calcium sulfate. Hemihydrate. Semihydrate or hemihydrate, both the way they call it. Okay, it's called as calcium sulfate hemihydrate. Hydrated copper sulfate. Hydrated copper sulfate. Okay, so hydrated copper sulfate, CuSO4 5H2O. 5H2O. It is blue in color, actually. Blue in color. So hydrated copper sulfate means CuSO4 5H2O. That is blue in color. But when you heat that, okay, that water molecules can be removed. Then you will get CuSO4 that will be white in color. When you heat copper sulfate crystals, no, usually the copper sulfate crystals are blue in color. Which is blue in color? They are actually hydrated copper sulfate, which contains copper sulfate plus 5 water molecules attached with that. With each copper sulfate molecule, it contains which each copper sulfate molecule, it contains 5 water molecules attached with that. That we call it as hydrated copper sulfate, which is blue in color. Okay. When you heat that, water molecules will get evaporated. Then you will get only the copper sulfate crystals, which will be white in color.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.